Hello everybody, welcome to my video training. Today I'm going to talk about the 802.1q tag and the native VLAN. So the 802.1q protocol is a standard protocol used by switches to multiplex VLAN traffic. And this protocol is a standard protocol, so it can be used by different vendors. So you just keep that in mind. So let's go and take a look at the 802.1q tag, how it is formatted. Okay, what is in the 802.1q tag? So in the 802.1q tag, let's first look at how many bits we have on the 802.1q tag. We have 32 bits, and those bits are divided into two big fields. Like the first field is the TPI field, which stands for Tag Protocol Identifier, and this is just like telling the switch that this frame is tagged, And the TCI field contains three fields: the PCP, which is used for quality of service, and the DEI is also used for quality of service, but with combination of PCP, and this one I'm going to focus on this one. This is the VLAN, the VID. This is where we're going to find the VLAN information. I mean the VLAN number, So right now what I'm going to do is I'm going to go and take a look at the frame, how the 802.1q is inserted in the frame. So the 802.1q is put between the source MAC address and the type field up here. So any frame you have on the internet network, the switch will always add the frame between the source MAC address and the type field. So let's go to packet tracer right now and take a look how this 802.1q tag frame works. So right now you see up here I have two switches, switch 1 and switch 0. Switch 1 has two PCs, PC1 connected to two PCs, PC0 and PC2, and switch 0 is connected to PC1 and PC3. And I assign PC0 and PC1 to VLAN 10, and PC2 and PC3 they belong to VLAN 1, which happen to be the native VLAN. But let's focus on the 802.1q tag, how it works. So let's say this PC want to send a frame to PC1. When this frame come to switch 1, switch 1 will add 802.1q tag to the frame. So it's going to add the tag. Let's go. It's going to add the tag up here between the source MAC address and the type field. And once this switch receive the frame, it's going to look at the 802.1q tag, and it's going to know that this frame is for a PC that belongs to VLAN 10, and it's going to send the frame out to PC1 up here. But just keep in mind that the PC doesn't have any idea about the 802 tagging. The 802 tagging is a language that is spoken between only the switches up here. So just keep that in mind. So right now what I'm going to do is I'm going to try to do a simulation and show you how what is inside the 802. Right now I'm going to go and explain you what is the native VLAN. The native VLAN is a VLAN that doesn't require a tag for the switch. So what I mean about that is, like let's say this on this demonstration up here, PC2 and PC3 they belong to the native VLAN, which is the VLAN 1. So when PC2 send a frame to PC3, it's gonna, when the switch receive this frame, it's gonna look at the VLAN number. It's gonna know that the frame is VLAN 1. And since VLAN 1 is the native VLAN, the switch will say, I don't need to add a tag because it is the native VLAN. And just keep in mind that only the native VLAN is the VLAN that doesn't require 802.1q tag. So just keep that in mind. And for the switch, the native VLAN is always by default VLAN 1, unless you change the configuration. So the native VLAN by default for the switches is VLAN 1. So right now let's go and do a simulation. So I'm going to show you inside the packet how the 802.1q tag frame is inserted. So right now I'm going to go to simulation mode up here, and I'm going to try to ping from PC0 to PC1 up here. PC0 to PC1 up here. So let's open up a command prompt up here. Okay, ping, and let's go and watch the packet. You see this packet up here, as it is leaving up here. Let's open up the packet and see. You see the packet does only have the outbound PDU because it is leaving PC0. So if you open up the outbound PDU, we see up here between the source MAC address and the type field there is no 802.1q tagging, because what I was telling you, the PC doesn't understand about the tagging. So the tagging language is only for the switches. So let's go and move the packet to switch 1, sorry. So now the packet is coming to switch 1, and you see up here I'm going to open up the packet and see what's going to happen right now. So you see now the packet have outbound PDU. So let me open up the outbound PDU up here, and you see what I was telling you. This is what we call the 802. The 802.1q tagging. And if you remember on my presentation, like what I show you, let me go back and show you. So like what I will show you, this is the TPID and the TCI up here. So, and you see that's what we have, the TPID and the TCI. And the TCI, that's where I'm going to focus right now, because that's where we have the VLAN number information. And if you look at this hexadecimal up here, the A, if you know about hexadecimal, A is for number 10. So that means this is the number for the VLAN we are using. This is the VLAN number that we are sending from PC0 up here. So I hope you understand this concept I'm trying to explain to you. So this is the VLAN number, and this is just telling the switch that the frame is tagged, you know. So, and let's keep watching the packet, you know. Okay, let's open up the packet, and you see the inbound PDU now, because it's leaving switch 1 going to switch 0. It have the 802.1q tagging, and the outbound PDU same thing. No, the outbound PDU now it doesn't have, because because this one it has, because it is on switch 0, and it is trying to reach PC0 up here, PC1 up here on this side up here. So, and let's go to sorry about that. Let's go to do a packet capture, and let's open up the packet again. Okay, so that's the concept I'm trying to explain to you for the 802.1q tagging. So for the native VLAN, in order to understand the native VLAN, I told you the native VLAN doesn't have a tag. So when this PC belonging to VLAN, the native VLAN, which is VLAN 1, send a frame, the switch will know that this frame doesn't require a tag. So let's try to make to ping PC2 from PC3, so we can watch the 802.1q tagging. So let me go to the simulation mode, and I'm gonna go to PC2, and I'm gonna try to ping PC3, and let's watch the packet up here. So you see this packet, it doesn't have we have the outbound PDU. Same thing like the example earlier. In this frame, we will not gonna have 802.1q tagging. So let's move the packet up here to switch 1, and let's open it. Open this one, and you see the outbound PDU. We will not gonna have 802.1q tagging either, because the switch will assume that this is the native VLAN. So I hope you guys understand what the native VLAN mean, because I see a lot of IT people, they don't understand. They just use this word like native VLAN, but they don't really understand the concept. But this concept is here. So we always, like for the native VLAN, you don't have frame tagging. So the switch is gonna assume that this is the native VLAN. It doesn't require a tag. So it's gonna send the frame untagged. And once this switch up here receive the frame, it's gonna look at the frame untagged, and it's gonna assume that it is for the native VLAN. That's why you always need to have the native VLAN configured with the same on both interfaces. Like what I mean about that is, if I have native VLAN configured on FAO2 as VLAN 1, I have to configure native VLAN. I have to configure up here switch 0 FA0/2 native VLAN 1. You cannot mismatch the native VLAN, because if you mismatch, let's say we mismatch. Let's try to mismatch the native VLAN up here, and we're gonna see the result. So let me go to switch 0 real time, and I'm gonna go and config T, and I'm gonna do interface FA0/2, and I'm gonna do, I think it's native VLAN. So I think it's switch port. Let me see the command is switch port. Yes, switch port native and VLAN, and I'm gonna put VLAN 10 just for fun, you know. And let's go back and watch the packet, you know. Let's try to ping back let's go to simulation mode. Let's try to ping PC3 from PC2. So I'm gonna repeat the ping up here, and let's watch the packet, you know, what's gonna happen. Take forward, and you see the packet is going, you know, but the packet will not gonna have a tag, you know. But let's see what's gonna happen when the packet get to switch 0. You see switch 0 assume that you see the switch 0 assume that the packet is for VLAN 10. So it's gonna send it, because it's gonna look, the only PC that have the port configured for VLAN 10 is PC1. So it's gonna, instead I'm trying to, you see the problem for mismatching the native VLAN. I'm trying to reach PC3, but instead of reaching PC3, I reach PC1, and the ping is gonna fail. So let's go back and check the ping up here. The ping is gonna fail, you know. Let's go back to real time. the ping is going to fail, the ping a timeout. So you have to be careful, just keep in mind that you cannot mismatch the native VLAN on the trunk link. So you have to configure. If I configure native VLAN for VLAN 1 on this side, I have to do it on this. I have to do the same thing on the other side. Otherwise, I'm gonna have some network issue, network communication problem on my network. So I hope you guys understand the concept of the 802.1q tagging and the native VLAN. So I would like to thank you for watching this video, and I will see you for my next one. Thank you.